Okay.
Okay, let me introduce Ishan. Ishan is a security enthusiast. He is a security, I would call it some kind of a security researcher, trying to
Yeah.
learn security. And now I have requested him to share whatever he knows on security. So he has chosen the topic OWASP Top 10. OWASP Top 10 is a interesting, initiative by security researchers worldwide. So I will leave it to Ishan to conduct the session. We will close
Okay.
exactly at 7 p.m. So
Okay.
please make best use of it. Thank you. Over to you, Ishan.
Okay. Okay. Do I need permission to share my screen?
No, you can share.
Okay. Oh,
The
let's
third
open it.
icon called share and then
Yeah,
share
yeah,
entire screen.
yeah. I hope my screen is visible now.
Not yet. I mean, can you open your slide? Ah, yes, it's visible now. Yeah.
Okay. So yeah, I'm EeshaanUndarBhat. I'm a final year student at Danan Sagar University, and I'm an application security intern at CISA Information Security Bangalore. So my primary work is in vulnerability assessment and pen testing for North American and European clients. So let's start the presentation. So the primary topic we are covering here will be OWASP Top 10 itself. What is OWASP? OWASP is the Open Web Application Security Project. So this is a global non-profit community-driven initiative. It's not a company. It's everything's maintained open source. They are essentially giving baseline guidelines for maintaining applications. They give guidelines for mobile applications, web applications, APIs, and most stuff on that goes on the internet. They provide the security guidelines for, and this is used as a baseline by multiple MNCs, companies, startups, everything. Yeah, upon this, there are other guidelines released by governments like NIST and all, but I won't be getting into that now. So now, what is OWASP Top 10? OWASP Top 10 is a list that is released every 4 years. I think I'm getting a bit of noise from someone. Then, okay. So yeah, OWASP Top 10. This is a list that's Sir, can you mute yourself, Chandrasekhar sir? I think I'm getting background noise. Okay. So OWASP Top 10, yeah, it's updated every 4 years. The latest version was released in November 2025, so it's called OWASP Top 10 2025. Then, yeah, this is the list, the latest list that's there. I'll be going over all of these in the session, and feel free to interrupt at any point, all of you guys, if you have any doubts. I'll try my best to answer all of it. Or if you have any doubts in general about security, careers, companies, or guidance, you can ask that in the end. So let's start with the first one. So broken access control. Broken access control is okay. One key thing in security is authentication and authorization. Authentication is ascertaining the identity of the user and providing access accordingly. Authorization is after authentication, where you decide what privileges the user gets. Now, broken access control deals with improper authorization. So, what happens is you are able to access, let's say you are a bank customer for now. And now, as a bank customer, you should be able to access only your account, right? But let's usually let me take an example URL. Let's say Kotak Bank, bank something something some characters, and let's say your account ID or information is being passed as a URL parameter itself. You'll see something of the sort question mark and some hashed value and so on. Now this hashed value is what is pointing to your account. Now let's say you try modifying this hashed value to some other valid hash. Or let's say this is not even that. Let's say you are going on Amazon and you have a cart, right? Now cart ID will be there. Upon modifying the cart ID, you shouldn't be able to access somebody else's cart. That is what broken access control is. So you are able to access. Yeah,
Yeah, so like broken access control means, for example, if like let's just say, let's just take maybe your example itself. So in
yeah,
Amazon, we have a database with all the carts and stuff and
yeah,
users. So now in the server, if somebody mishandles the privileges,
yeah,
some user will get like some user will get extremely large amount of privileges, so they
yeah.
can also touch others cards like that.
Yeah, that is essentially what broken access control is. Other cards could be there. It could be the admin panel on the other side. As a customer, you shouldn't be able to access the admin panel. So
Oh
there
yeah,
also
correct.
it could be there. And then it could lead to, again, privilege escalation is an example of that. So you are increasing your privileges through broken access control. Other is modifying. Then there is you being able to modify data without authentication. So let's say you
Oh,
haven't logged in, you have logged out of your Amazon account, but still upon going to that URL, you are able to modify your cart, add stuff, order. That shouldn't happen, right?
oh yeah, correct.
Yeah, so that is where this comes in. So mitigation is essentially a solution for each kind of vulnerability. It's there. So now one mitigation is server side authorization. So you have to compare and ascertain identity on the server side, client side, because you can modify, right? If I'm an attacker, I have full control of what is running on my system. So if the authentication authorization is happening on my end, I'll be able to just go inspect page, modify code, and see that that's because everything's running in my browser. Then there is deny by default or principle of least privilege. So as a designer of the application, you should ensure that every person is getting the bare minimum privileges necessary. Even if you think it's insignificant, by mistake also you shouldn't give extra privileges to unnecessary entities. Let's say you might think that it may not do any harm, but that can come to bite you back later. I hope broken access control is clear. If anybody has doubts,
Good. I think
otherwise
we
I'll give
can reserve the questions for the last 15
for the
minutes.
end.
Yeah. Hmm.
Okay. So then there is security misconfiguration. This is more of a human error thing. So what happens in security misconfiguration is, let's most service providers, most routers, physical devices, or let's say account based stuff. So your CI/CD pipelines ke liye, they end up
Sir,
using default or yeah. Ishan.
your video and voice is kind of breaking.
Okay. What was the last thing you heard?
No, Kishan, I think
Hello, it's
let him
completely
continue.
frozen.
Let him continue. He can't do much about it. Yeah, let him continue.
Okay.
Kishan, let's
Okay.
have the questions at the end, please. Okay.
Okay, okay. Security misconfiguration, essentially, you are not enforcing strict security policies as an IT admin. You're not changing passwords frequently, weak password policies, allowing weak passwords, or periodic, not changing them timely enough. Usually, companies should have policies for changing every 1 month, 3 months, and so on. Then, for when it comes to cloud configs and all, identity access management is what handles your authentication authorization privileges on the cloud side. So having weak policies on that side. So this is mainly having improper or bad security due to human error of setting up or human laziness, essentially. And the mitigation for this is hardening configurations, auditing every few times, and yeah, fixing up stuff. Then there is software supply chain failures. Software supply chain. So we know that current software, let's say web applications, mobile apps, all of them have continuous pipelines for pushing updates, introducing new features, and so on with minimal downtime. So now here in your software supply chain failures, what happens is the attacker tries, instead of attacking the application itself, he tries to attack the supply chain. So let's say your project relies on some specific repository or some specific dependency. There, instead of trying to, let's say you have an application that does video streaming. Now this video streaming application might be using some specific browser based video player that some other guy developed, and he's maintaining that application separately. Yours just pulls it from there and uses it. So now if I inject some bad code into the video player's application that you are using as a dependency, then essentially you are making your application vulnerable, right? So that is where your software supply chain failures occurs. Recently, there was, I don't know if you guys have followed, but what happened was we use Node.js commonly for our web development. So some people had taken over one of the Node.js is an open source project. So there,
Yeah.
yeah, some people took access of maintainers of the open source project and injected malicious code into one of the packages that the Node package manager was maintaining. And now that happened to be such a package that a lot of people, a lot of other projects depended on. And because of getting this one entry point, everybody who uses that package was vulnerable, but it got patched, got caught and patched pretty quick, but it did create a lot of noise.
Oh,
So
so like it's like for example, injecting some kind of coronavirus or something in a place where a lot of people touch.
yeah, yeah, equivalent to that. A lot of people depend on more than touching. So
Ha, ha.
putting it to your school or yeah. So now mitigation for this is something. This SBOM is essentially software bill of materials. What companies should be doing ideally is keeping track of every dependency, every script, every change they're making, and having this robust list that tracks everything will help you catch such incidents early on. Because as a client or as a user of the repository, you can't do anything other than isolate the incident and hope for the original maintainers to fix it. Then there's dependency tracking. Again, that falls under software bill of materials. Signed builds. So before pushing updates, maintainers should verify it, and you everything should be tracked. Shouldn't be blind pushing of changes. And strict continuous integration policies again falls under the same thing. The next thing that we'll be going to is cryptographic failures. So now here, this is another issue that occurs due to developer laziness, you could say, because there are so cryptography is used widely everywhere. You have encryption and hashing that are the primary methods. So in well, that comes under your cybersecurity side of things. So hashing is unreversible, encryption is reversible in a sense, and requires a key. Now what happens is there are previously there were algorithms that have been phased out now. So there were certain sets of cryptographic algorithms that were used in the 90s, 80s, or developed back then that people thought these things were secure, but now they have been proven that they're not secure, like with mathematical proofs and all, but they're still being used in application development. So now MD5 or SH-SHA-1 hashes, these are very easy to break. There's something called rainbow table attacks you can do, and there's multiple automated tools that can break these. And so if you're still using insecure algorithms, well-known insecure algorithms, an attacker can decrypt your data within seconds. Another thing that you are seeing is HTTP. The protocol itself is a protocol for transmitting plain text traffic. So whatever data you're sending over HTTP is just HTML code that you're sending from server to client, nothing else. Now what happened is this is insecure. Obviously, it's subject to man in the middle attacks. There's no verification of who is sending, and yeah, they're very insecure because it's plain text. So something called TLS was like brought into place, that is essentially encryption for HTTPS traffic. So HTTP with transport layer security, or now TLS has been phased out for SSL, secure sockets layer. So this what is the difference between HTTP and HTTPS. So some sites or some web applications or some mobile applications, yeah, during their development phases for easier debugging, they might have left everything on HTTP and they might have not turned it to HTTPS. That's another point where here the vulnerability is due to not using cryptography at all. So anything cryptographic related, that's what comes under cryptographic failures. Now let's come to injection. This is the juicy part of the presentation, I'll say. So injection is you trying to get code execution on the server side or on your side, or basically ruining things through code execution. It could be SQL code, it could be JavaScript, could be Python or shell code also. So what this happens when let's say you take an example of a web application or any other application that is being interfaced through the internet. Now, obviously, you have input fields here. So, input fields are the only way for you to send data across, right? Now, these input fields are getting processed on the back end by different mechanisms. Uh, uh, it could start out as a generic string, and then maybe regex rules are applied, serializers, deserializers are there to make sense of the text pass. So let's say a name, you're sending a name or a phone number. There'll be backend rules in check to say, verify if it's a name or not, or a phone number or not. So now, right now, this is not that much of a concern because most library you were probably using SQL, NoSQL, or other services database interactions through libraries, right? You're not crafting raw SQL queries into your code. Maybe interacting with the database itself, you could be doing it through SQL queries if you're directly interacting. Otherwise, if you're
But Ishan, whenever we are doing REST API using Java, at least
yeah
when I am coding, I am still putting raw queries into the
that
Java
is an
code.
unsafe. Yeah, so what happens is when you're doing raw queries in Java code or other languages, if you're not structuring the queries properly, let's say I'm searching for some user on Facebook, and there on the back end, your searching mechanism first takes your name and then does a lookup in a SQL database with that name. Now, let's say I, instead of entering a name itself, I'll enter a SQL query. I'll put something like or one equal to one, and one equal to one, or and then show tables or whatever. Now, if that shouldn't get executed ideally, if it is getting executed because of the bad query design, then yeah, that's what leads to SQL injection. Let's say even for JavaScript, what happens is whatever input fields are there, if I shouldn't be able to send my JavaScript code there and it shouldn't get executed, right? That's where your JavaScript execution happens. It could be happening on the server side or the client side. I'll be going into them later once I cover everything. I'll go deep dive into injection. But
Yeah,
a basic
good.
mitigation for this will be ORM models. So Java, as Sir said, he's using raw SQL queries. That's not a good idea. What ideally you should be using is ORM models. Basically, libraries for that handle your input parsing for you, because they are more robust and they go through a lot of checks before going to the final query. There'll be filtering of inputs. Let Common payloads will be there for SQL injection, JavaScript injection, and so on. So you could put regular expression based rules to filter them out, to flag them, to maybe alert the server side guy that some attacker is trying stuff. Yeah, so that's where injection happens. Injection is basically user input, pay, you're sending bad code, harmful code, and that is getting executed. Okay. Then there is insecure design. Insecure design, this is now here. Previously, whatever we discussed was a flaw in the library itself, flaw in the code, or flaw in how you process inputs. Now, insecure design, what happens is the flaw is your code may be working perfectly, but the problem is in your architecture itself. Let's say you're making a checkout payment on Amazon. Now, ideally, what you should be doing, verify if the user is the same person who's making the checkout, or verify the user. Then maybe verifies payment information. He shouldn't be using somebody else's card. Then check for this thing. So maybe if you're charging his card, check if it has the balance, and then allow process the payment. And all these checks should be in place before you finally approve the order and send a message to the database to dispatch the order, right? Now, if you don't have these checks in place, or if these checks are not sufficient, let's say you're just taking username, password, saved payment data, and you're processing it, you're not doing any kind of authentication and all. This is a design flaw. The code may be working perfectly. There's no code level flaw. You as an architect have failed. That's where your insecure design comes in. And the mitigation for this, and maybe you have not expected certain types of attacks. Let's say let's say you are still doing password verification, but you have not rate limited your backend or API. Then the other guy, the attacker, can run brute force attacks. So that is doing threat modeling is essentially covering all that. Threat modeling is you hiring someone, or you thinking as an attacker as what possible things could happen with my application, and writing code accordingly, not directly writing code for the purpose itself. So that is what is gets covered in insecure design. Then there is authentication failures. Authentication is again, as I listed, the process of ascertaining the identity of the person and confirming that the person is who he says he is. Now, what happens is in some applications, maybe you are able to bypass, let's say, multi-factor authentication is not there. Then I could exploit some feature like the forgot password feature, social engineer. So, forgot password, pay what will it ask? Maybe date of birth, the school you went to, and so on. This is easily available, publicly available information. Maybe you go check his Facebook or Instagram profile and get that. So this is insufficient authentication. Another thing that could happen is maybe for this the solution is using multi-factor authentication. Even though you're using a password, ask him for a pass key, fingerprint, or ask for biometric authentication, ask for an OTP, and so on. Another thing that could happen is implementing this MFA incorrectly. Let's say you put OTP based authentication or some kind of multi-factor authentication, but the way you've coded that authentication mechanism is wrong. Let's say OTP you're sending, OTP is getting reflected in the browser itself even before the guy enters it, or the comparison happens on client side. Now this is an obvious flaw, right? The guy could go inspect code and check your OTP that is getting sent, or maybe the OTP is getting sent in the response but is not part of your HTML code. So again, there are softwares for intercepting traffic. There's Burp Suite, Wireshark, and all. Wireshark for packet level interception. Burp Suite for intercepting individual request responses. I'll be sending you links to these in the chat box later. I would encourage you guys to check it out. So that is what is covered in authentication failures. Now there is software or data integrity failures. Here, software or data integrity failures, what happens is application code data and or updates are getting accepted without verifying their source. Back then, when I said supply chain attacks, or when I went to software supply chain failures, here what is happening is someone is hijacking the software supply chain. So maybe hijacking a dependency and so on. Now the software data integrity failures, what happens is, let's say as an attacker, I am able to push an update, though I'm, let's say I am, what example can I take? Okay, Subway Surfers is there. Now Subway Surfers as a game, it should be running just the game and it shouldn't be accessing your personal data. It shouldn't have access to your files, phone numbers, contact history, and so on. Now, as an attacker, if there's improper code there, what I could do is, even though I'm not the publisher of Subway Surfers, I could push an update only to your device that changes code such that it acts maliciously or steals your personal data, or maybe a keylogger to check everything you're typing and so on. So if the application itself is not designed to handle updates, verify their authenticity, and then apply the updates, that's where your software data integrity failures happens. So again,
Oh,
this,
so
yeah,
like basically telling okay to things without like
checking.
knowing. Yeah.
Yeah, okay to things, and then it should be not just checking if the update itself is valid, but verifying if it's coming from a trusted source. There's key-based mechanisms to ensure that the source is the same thing. You get SHA-256 keys
Huh.
usually. When you go into Linux, like package management and all, if you're adding your own private repositories, there you'll deal with this. So you'll have to add your own trusted source keys, and then that will be used every time. Unsigned updates, it won't allow itself, or it'll give you warnings. Then there is logging alerting failures. So previous cases may we've discussed the application itself getting hacked, right? Now let's say the application has gotten hacked now some way, or it's misbehaving. Now the next best thing is you should be reducing the impact of the hack, right? Now if your logging and alerting is not set up properly, then as somebody there is in security there is red teaming and blue teaming. So the blue team is what handles the defensive side of things. Red teams essentially simulate attacks as bad actors. Now what happens is the blue team guys are on alert all the time. and they are what is responsible for handling when attacks occur. Now, if your logging and alerting features are not set up properly, maybe you've set up rate limiting for, let's say, password to prevent brute forcing there. But now, when this rate limit gets triggered, if you do nothing about it, let's say you block block the guy, he'll just wait for a while and then try to brute force again, right? He'll just set a timeout that matches your rate limit and brute force again. What ideally should happen is to alert the defensive side guys, so they can go check the incident and then try to find out who he is, what he is doing. This is the nowadays this is handled through SIEMs, that is essentially management software for
So nowadays it is handled through what?
SIEMs, software, not software, security infrastructure and event management softwares.
Okay.
Okay, so these are essentially dashboard type softwares for designed for blue teams. They'll be able to monitor all alerts, monitor the status of alerts, and so on. Maybe uninvestigated incidents will be listed on one side, and you could put your own notes for others working on the same issue, and so on. Essentially, you have GitHub for collaboration for development. Here, this is for handling alerts and improper behavior. Then there is mishandling of exceptional conditions. This specific entry is new to this year. So the previous OWASP top 10 list didn't include this. So now mishandling of exceptional conditions is when you have improper error management or exception management. So maybe you're taking some cloud resources and you're not releasing them properly after your job is done. That could lead to hogging up of your resources. So another guy who, as an attacker, could DDoS you, even though he's not getting a sensitive information. He could DDoS you by just occupying all of the resources, right? Making payloads that take up resources, and because you're not releasing it. Or maybe improper allocation could be happening. So when you run out of resources, maybe it's taking existing users or existing processes ka resources reassigning. That's an example in cloud. On a software level, what could happen is your Stack Overflow type errors. So Stack Overflow, uh, let's go to say C++ has improper, what is it called? Improper format specifier based vulnerabilities are there when it goes to full binary level applications. If if it's processing input improperly and all. Or yeah, you could trigger memory leaks. You could like overwhelm the software on the other side, or on the server side, and that could lead to printing information, the unintended information that's in somewhere else in memory. So basically, if exceptions and errors are not handled properly, then that could lead to either DDoSing, or it could lead to sensitive information exposure. So this was there. The next slide is Q&A, but I wanted to go through your injection. I said I deep dive, right? So now injection may there is SQLi, no SQLi is basically, as sir said, you're using raw SQL queries on the back end, and there it's getting processed. I didn't have this time to make slides, so I'll be using this image as a reference. So SQL injection may there is in-band, inferential, and out-of-band SQL injection. I won't be covering out-of-band right now. So in-band SQL injection, this is where whatever you're doing, whatever payload you're sending, maybe you're sending a SQL query. There's plenty of payloads online you can check up for inspiration. So whatever payload you're sending, uska response you are seeing on your end. Maybe it's coming as part of the response. Maybe it's reflected on the front end itself, and so on. So what happens is if you are getting an error, let's say I put a SQL query and I ask it to print information from a table that I'm not authorized to. Let's say I'm in the username field, I'm asking it to print password hashes for a different user. Maybe I'm using and or a statement, and I'm doing that, and that doesn't get executed. Maybe you have half and half checks and balances in place, so it is triggering an error. Now this error could reveal what kind of database is there. Obviously database softwares will also have inherent errors, and these things keep getting patched with updates. So maybe he's using an outdated database. In that case, you could directly hack into the database with like ready-made exploits that are made by others. Then another thing that could happen is that even though it doesn't give you the passwords, or maybe it doesn't give you the list of users, it could be revealing something else. It could be revealing the number of systems, or in the failure itself, or the error itself, it could be telling revealing information about the target system's architecture. Maybe it's saying Windows ka some error that got triggered. Maybe not the SQL error itself, but that is showing that the SQL query itself is getting executed. Then there is union-based SQL injection. Union-based, what you do is you essentially pass a true condition. So 1 = 1 will always be true, right? So now what you do is to trigger the SQL injection will be doing this, and then using and or not and so or, and then you will be giving your payload, whatever show and so on. Now this will get executed because the first condition is true. That is your union-based SQL injection. Now, in your inferential SQL injection, or blind SQL injection, is basically whatever you're sending your payload, you have no direct response to that. You have no way of knowing if the payload got executed or not. Now, what you have relying on is essentially guesswork. So let's say I sent a payload. Now I'll cover time-based words. So I sent a payload. Now if the server has proper checks there, then it'll know it's a SQL injection attack, and it'll just discard the payload. Right? It won't even go to process the payload. So your response time will be much faster. Maybe I'll get it in 10 milliseconds. Now, what could happen? The security mechanism on the other end, what it could be doing is maybe it's letting the SQL query execute, but now because it's revealing sensitive data, maybe for outgoing request, he could have put security, right? He could have put rules that okay, if it's revealing names, if it's revealing phone numbers or whatever this thing, then don't let this request go out. Now the for this essentially you're waiting for a timeout on that side, because it's not sending a request, you are not getting a request, so now your response time will be higher. Now you can guess that the SQL query itself is getting executed, but the server is not letting the information out. Now what you could do is there are essentially SQL payloads that will let you escalate from SQL to essentially a bash shell, if it's Linux, or essentially a shell code. You could do that. So if you could set up a listener on your end and trigger this, it doesn't have to reflect anything, right? It just has to execute the query, and then the system will make the request, and then you'll get your shell access. Then there is blind boolean based SQL injection. Now blind boolean is similar to error based. What you will do is in error based SQL injection, you are getting SQL error itself that is propagating to your front end. In blind boolean, what happens is the SQL error may not get propagated, but let's say you give your payload, and for a true payload, let's say I do 1 = 1, I pass it. Now because it's true, and if it executes, it'll probably not reveal information, but it'll return a 200 OK on HTTP. And if I do 1 = 0 and try to pass it, then it's a false thing, right? It shouldn't get processed ideally, but if he is not coded it properly, that will lead to a SQL error. But now the guy would have coded that in such a way that the error-based SQL doesn't happen. So he tells, okay, SQL errors don't get printed on the front end, and you discard it. Or he may not have handled the error at all. Some other component is handling it. It might end up giving you a HTTP error. So now, if it's giving two different responses, ideally it should give 200 OK for everything, even if you're trying to say or do SQL injection, because it's not disclosing anything to the attacker, right? So now for blind boolean based SQL injection, it's giving you a HTTP error. Now in your HTTP error, you will know that something is getting executed on the that side, even though it's not telling me what is happening on that side. It could be causing an error, it could be executing. Now this was for SQL. The another common point of injection is XSS. XSS stands for cross-site scripting. Okay, so I hope all of you guys are familiar with JavaScript, or you've done some part of it, or how the code works, right?
Yeah, basic understanding of JavaScript. Yeah.
Okay, now JavaScript, how can we define JavaScript for a website? Either you can put it in a script tag, or you can put it in a separate static script file, or you could be sending JavaScript in the response, right? Dynamic for dynamic websites. That is what is covering our three types of XSS. Now, XSS is essentially SQL IMA. Your whatever was handling your inputs, the input was trying to trigger a SQL query. Now here you are trying to get JavaScript execution. So now the first thing is DOM based XSS I'll be covering. So DOM based XSS is basically DOM is the document object model. So your client side XSS basically. Now whatever input I'm giving, let's say I'm putting a password and a username. Now let's say my authentication is, though it's bad, I'm doing it client side, or maybe I'm using this thing. Maybe I'm asking it to request for the profile picture based on the name, but all this is on the client side code. Now what I could potentially do is whatever input I put here, okay, whatever input I put in this input field, this is probably going through some sort of JavaScript, let's assume. Now if this script if this JavaScript block is in my browser itself, then I could try to escape this script tag, script slash is there, right? I could try putting my malicious payload here. So now here by him saying alert equals one, alert one essentially triggers a pop-up. This is a test script that he's doing. Okay, so now alert equals one shouldn't be running from user input. Let's say you took ID and ID is getting processed in some script block. Now if I put ID equals alert one, or ID is as this and it's executing, that's an example for your browser based XSS. Maybe I could try to steal your cookies and so on. So I could do, instead of alert one, I could do alert and try to print your cookie. That gives me the pop-up here, or maybe I could ask it to send it to me as an attacker to a different site. Then
So,
there
so
is
Ishan, one question. Many
yeah,
websites like banking websites ask us to disable JavaScript from the browser, but when
yeah,
we
that is primarily
disable,
for the,
but when we disable JavaScript, the pop-up kind of effects we will not get. So, how do you manage
yeah.
both of them?
No, but so this pop-up shouldn't get triggered. That is the ideal condition. If it is getting triggered, that is wrong. So
So
they
that
are
means whenever there's a pop-up, that's not a good HTML design, is it? Hmm.
no. Again, pop-up should be use case specific. Now, I'm not telling asking the designer to give me pop-ups. What I'm doing is I am triggering my. So the designer has his code. He has made his website. Now let's say his website doesn't include any features for pop-ups, and me putting this alert one, or trying to put a pop-up there, is essentially telling me that my code is working. Now if pop-up is working, I can put some other code, right?
Okay.
I, if this pop-up is working, this pop-up is just for me to confirm that XSS is there. If it is working, then instead of I would obviously not give the pop-up to the victim. I'll probably steal his cookie, send it to my site. I'll write the JavaScript code for that, because I know it is executing. So yeah, the banking sites, they tell you to disable JavaScript for this exact reason, because they want all the processing to happen on the server side, where it is more secure. Now that I told, then the next one is stored XSS. Now stored XSS is what happens when, let's DOM based, I told everything's client side. No, nothing is going to the server. It's everything's happening on your side itself. For stored XSS, what could be happening is you send some payload, and your website is designed in such a way that it is executing JavaScript improperly. And now I'm storing a payload in your database. Let's say now I'm creating a user, and my username is a XSS query, or a cross-site scripting query, or it could be any kind of JavaScript query. I could say steal admin cookie and send it to me as this, or I steal current user cookie. That itself is my username, and it shouldn't get executed, but it is getting executed. So what is stored XSS is doing is, you are sending this query that is getting stored in the database. Now let's say Facebook Pay, you've done this on your profile. Your username is essentially JavaScript code to steal cookies and send it to your some private site. Now what happens is, every time somebody goes to your profile, it will steal the cookie from that browser instance and send it to me. So that becomes a danger for everyone who is viewing the stored data. That is what your stored XSS is. Now, when it comes to reflected accesses, what happens is you are passing some data, let's say name or whatever, and now it's not getting executed in your browser level, but once it goes to the backend and let's say you entered your name and now it should show your name on your profile, right? Now, it instead of sending your name as plain text, it's sending the same variable back. So if it's sending the same variable back, it's not exactly sending my name. It's sending the same. If I enter JavaScript, it's sending me JavaScript back. It's not sending text back, and that JavaScript is getting executed. So essentially, reflected accesses is where your cross-site scripting is getting reflected in your response that is coming from the server. So these are popular ways of injection. Again, if there are other cases where injection can occur. So but basically it happens when you're dealing with user inputs. So the injection could occur in object deserializers. So I don't know if you guys have gone through this, but where for transmission data gets encoded into some base64 or some other method and for easier transmission. Now, if the deserialization logic is bad, then that could lead to code execution. So yeah, that is a deep dive on injection that I wanted to go through. Now I think I'm open for Q&A if
Yeah, Ishan,
anybody
one
has
question to
doubts.
you. Many people
Yeah.
who want to work on security, they use Kali Linux. Can you tell us about
Yeah.
Kali Linux?
Okay, so Kali Linux is a Debian based distro. So Linux as it is basically just your Linux kernel. It's called GNU Linux. So Linux kernel itself is Linux, and then there is GNU ka utilities. That is your basic commands ka implementation, ls, cat, and so on. Now this is the essential Linux core. Now what different distros do is package this up with other applications. Now with your Linux core, you are just able to get very basic functionality. Now as an operating system, to make it usable, you need other utilities. You may need a text editor. You may need compilers for programs. You may need authentication mechanisms for login, log off. Maybe you need a GUI. So what these different distros, let's say Ubuntu, Kali, Debian, all these do is uh, package all these applications together with Linux and then release it. Now, different distros are made for different purposes. So, Debian is a generic distro that gives you that sticks to using everything open source, and then it's essentially saying you do what you want with it. I'm giving you your basic functionalities. Now, Ubuntu maybe taking it and making it user friendly for beginners or Linux Mint and so on. There are certain distros that are designed for game compatibility that come with drivers and so on. Like that, Kali Linux is essentially coming packaged with all my security tools. And there is alternative. There is Garuda Linux is there now. Parrot OS is there as competitors. All these Linux distros are essentially coming
So,
packaged with
can you tell us
security
about
tools.
this Garuda and Parrot? Can you tell us what?
Okay, they are essentially Kali Linux competitors. So they also come preloaded with tools. So let's say you start out with Ubuntu itself. Ideally, you can do everything that Kali does on Ubuntu, or you can do that on Debian, or you can do on Fedora or everything else by installing the specific tools. The only thing you're doing by using Kali, Garuda, and so on is just minimizing the setup time because there he's sending all the tools ready-made. You don't have to set anything up. Anything you can think of, it's there. In other distros, you may have to install and use. That's it.
So, sorry, which is easier to deploy, Kali or Parrot or?
Right now, Parrot is the most popular one because it covers a more wider range of tooling compared to Kali.
Can you just display the URL if you don't mind? Parrot.
Yeah. Parrot, again, Parrot OS was developed by Parrot Security. So yeah, here you can go download it. These guys again, security company, they do security testing and so on, and they made a custom OS for their use case. Again, if you notice, it's pretty similar to Kali. It's using the same desktop environment and so on. Now again, Kali was also made by another security company called OffSec, and I'll be talking about their certifications and all later on. They're very prestigious. So yeah.
Okay. Yeah. Any questions, Dhyan, Rashmi, Srinivas?
I think Kishan left the call or maybe got disconnected. He had
No, we
questions.
had very less number of people. About
Okay.
5 or 6 people left actually.
Okay. So yeah, do I go over certifications or like career
Yeah,
paths?
please. Hmm.
Okay, certifications. Okay, one thing in security that you'll hear a lot when you interact with people is it's not something for freshers. This is only partially true. The thing is, security, if you want to get into this domain, you'll need a lot of background knowledge in other domains, maybe networks, maybe in application development, and so on, depending on what kind of security you want to get into. Another thing is security is not one monolith. There's no getting into cybersecurity. You have to get into cloud security, mobile app security, maybe malware development, and so on. And all of the most of these career paths require experience in development or again network management, cloud, and so on before you get into the security aspect. But two roles that you will see open for freshers in India at least is your VAPT roles and SOC roles. VAPT stands for your vulnerability assessment and pen testing, and SOC is the security operations center. That is your defensive side, one offensive, one defensive side. So now what happens? Ideally, what happens is if you show your fundamentals are strong, then the company should hire you, train you, and then maybe take you for these two roles. You get experience in these, go they rise up the ranks and go into the domain you want. Or you could start out with a development role and then go to, jump to security and go that way. But in India specifically, there is oversaturation of the market. There's too many people competing for everything. So there is certifications in place. These certifications, originally they were designed for industry professionals, for people already working in companies. But in India, because there is a higher supply of people, uh, to stand out, you may need certifications. So one popular certification that you'll see everywhere is your OSCP, OffSec Certified Professional. This is a offensive security certification. This costs around $1,500, 1,600, I guess. Approximately after conversion, current rate 2 lakhs. It's yeah, this is something you go if you have a lot of experience in security already. That is what this was designed for. But if you have are like very sure about getting into security, you could aim for this. But yeah, it's fairly hard. It's a 24-hour live monitored exam. You can't take rest, but then yeah, you're doing a real world attack on their systems and proving that you can do it. This is the then there is one certification that I myself have done, that is EJPT. This cost you this is basically a network security certification, and this will cost you roughly 15k, 12k to 15k on discount when there is sales going on. They give you your course material. They will cover your network security side of things. Though they say red team, entry level red team and all, they'll cover network security. Another thing I want to emphasize on is all this, whatever certifications I'm going to mention, all their resources are available on the internet for free. Either through I'll openly endorse piracy, whatever, because of the costs are so high. So it's not realistic for us as students to be trying for these. So yeah, there is all free resources are there. If you want these specific courses, certification courses, those also dumps you'll find, exam practice material you'll find. So I would encourage you to go for that, because certification is just a HR filter. It doesn't show that you have skill. uh, it is just getting your foot in the door. Later, you have to prove yourself in the interview anyway. And depending on market fluctuation, maybe they'll be ready to hire without certifications also. Another certification that I would try to tell you to be alert of is CH, Certified Ethical Hacker. This certification is like a very basic certification that will cover basics of security and everything. This tries to make you a jack of all trades. It doesn't help you specialize in anything. It'll just try to touch upon everything: defensive, offensive, development, maybe networks. It'll try make you touch everything, but you won't ensure mastery in anything. So this HR people like it a lot. It'll get your foot in the door, but once you go for technical interviews, it has zero value. And the worst part is they what they do is for professionals who have 2 or 3 years experience, it'll cost them maybe 15 20k. They can take the exam directly. They don't have to purchase a course. For students, they'll do mandatory. You have to buy the course. That will make drive up the cost to like 55 60k to 1 lakh. and they don't have transparent pricing. I wouldn't recommend this at all. Another certification that is not that popular or underrated but good for the knowledge is CPTS. This is Certified Penetration Testing Specialist by Hackbox. These guys charge $300 for the certification. I told you OSCP had 24-hour exam, right? This CPTS exam is a 7-day exam, continuous monitored. Okay, so 7 days of you'll get access to essentially a full company network, web app. It covers every domain. And when I said CH tries to cover every domain and doesn't let you master anything, right? This will get you intermediate or enough knowledge to get a mid-level job. The certification itself may not be recognized that much, but the knowledge that you get from doing the certification is immense. I myself am targeting for this. Another benefit is these guys charge a lot for obviously the service itself is paid. Your Hack the Box is a platform where you can practice cybersecurity, defensive and offensive cybersecurity, and they charge like $10 to $20 a month for they charge $20 a month for their subscription, for their access to their labs for you to practice on. But for students, the if you give your student email id .edu ka any id, you get a student discount and you can get it for 700 rupees a month. And this is one thing that I personally that I started this year. Maybe I knew about it before. I would recommend you guys that 700, if you're even logging in for 1 to 1.5 hours every day, it is worth it. The amount of knowledge you'll gain, and it is gamified. So once you start it, you will probably quit gaming and get to this, because the point system, the way it's structured and all, it's very good. Then some free resources that I'm pointing out to you guys is over the wire war games. This I would advise you guys to take it up as a personal challenge. Over the wire bandit you can go to. This is essentially war games is simulating attacks. What happens is these are different series on the over the wire website. This starts with your Linux basics. Now what happens is the ideal way to solve it is read this, then they ask you to go to man pages. Man pages are essentially manuals for each command. Follow the instruction to the pin. Don't Google. Don't. Google. Yeah, maybe. Don't use AI because you'll just be cheating yourself. Don't go to Stack Overflow. Don't view solutions for these. And what happens is essentially you do an SSH connection to a terminal that they give at level 0. And every level pay, if you solve the challenge, you'll get the password to the next level. And you can keep continuing. You can store the password on the side. Password gets changed for like every month or so. And you can practice here. So by the time you reach your level 34, you'll be proficient in your Linux. Even if you're not into cybersecurity, just for you to brush up your Linux, this is very good. And now going
So
to
sorry,
other,
I was coming to the next question. So
yeah,
overthewire.org will help you to improve your Linux knowledge. Mhm.
no, over the wire mein, this bandit series is for Linux. Now once you finish bandit, you will go to natus. Again, here there are levels. So each of these will cover one by one security domain. At one point, you'll again here natus covers web security. Next, Krypton lets you deep dive on cryptography. Then reverse engineering, you'll actually be going debugging compiled binaries, reversing JavaScript code for one level, maybe Python code for another level, maybe you're writing assembly code for a different level. So it'll give you a very good deep dive on reverse engineering. Again, binary exploitation, here your stack overflows and all comes in. So yeah, after this point, it's binary exploitation mostly. But
So just
each of
tell me, who do you think would have developed this overthewire.org? Some one
it's
company or one individual or?
no, no, this is as far as I know, it's from a university that they started internally for their practice, like for their
Okay,
club members type,
okay.
and then they release it publicly. Another thing is Pico CTF. So Pico CTF, this was developed by Carnegie Mellon University guys. So this was there's something called DEF CON that happens in Las Vegas every year, and this is like the ultimate security conference. Everything from hacking a refrigerator to hacking your Tesla cars, maybe your phones, web applications. Maybe there are people hacking insulin pumps there. Everything, or even physical lock breaking. anything security related, that not just cyber security. This is the ultimate conference. So these guys
So, what's the name of the conference?
DEFCON. You can hear find talks about it online. So latest cyber security developments or security developments in
How do
general
you spell it?
get revealed.
TSCON, is it?
No, DEFCON. I'll put it
DEFCON,
inside.
DEF. Got it.
Yeah,
I
yeah.
also hear
So this
about Black Hat or something like that. Mhm.
Black Hat USA, yeah, that's another conference. So this DEFCON pay, essentially CTFs are what is hackathons are for developers, right? CTFs are similar for hackers. So you perform exploits, like, or again, you do cyber security challenges in CTFs, capture the flag. So essentially, at the end, you'll get a flag, and which you submit for points, or maybe you maintain access on a system and so on. So this DEFCON CTF is one of the hardest CTFs in the world, and if you get in there, like, even if you're, let's say, you're coming from communist Russia, also. People who win the CTF, these guys get hired directly to US, Israel government and all. They give you, like, there are schemes for giving you citizenship on the spot, and like taking you in. So this is like the CMU's specific CTF team was on top of this DEFCON CTFs for like 6-7 years straight. And this Pico CTF was something that they developed internally to train their university students. So every time they pass out, they have to replace club members, right? To keep the CTF team up. So they made the CTF for them. Then recently they have released it publicly. And I've again just heard anecdotal knowledge. This is something that if you are considering studies abroad, and if you want to go get into CMU, your challenge is solved, and Pika CTF is also something they're looking into apparently. This is university specific though.
Okay,
Yeah,
great, great. Yeah, we have 2 more minutes left for any questions. Srinivas,
yeah,
Rashmi, Dhyan.
Yeah. Firstly, thanks, Ishan. Thanks for the wonderful session. I have two questions. One is, I've heard a lot about Try Hack Me. So Try Hack
yeah.
Me is,
Okay, so I was gonna tell that I had it open on here. So Hack the Box and Try Hack Me are essentially competitors. They do the same thing. Again, Try Hack Me also now they have released regional pricing. They essentially they do the same thing. You are able to launch labs on a cloud instance, and then you are able to practice attacking on it, or maybe
okay.
defending as defensive side. But Try Hack Me is more beginner friendly, I would say. If you have the domain knowledge, if you have your network fundamentals sorted, if you have your essentially CSE degree ka whatever you're supposed to know, if you know it properly, then I would recommend more towards Hack the Box. Track Me is for someone who is coming raw into this.
Okay, okay. Last 30 seconds. You're talking about hacking a fridge and all this, right? So right
Yeah.
now, what do you think about OT security, like operational technology, where all the manufacturing is also getting
Oh yeah.
digital?
So one, yeah, that is very critical. I remember like one incident that got famous. The U.S. government managed to ruin I not Israel, Iran's or Iraq's nuclear refinement. So uranium enrichment facilities through attacks to
That was called
their OT supply chain.
Stuxnet, right?
Stuxnet, yes,
Yeah. Mm.
yeah. So yeah, that's a very good example of what how critical the impact could be, and there's importance of OT security, and that's I think a field that will stay for a long time.
Okay, okay. And one more last question. Like these, so many products have ISO standards, right? So
Yeah,
does these do these codes or some softwares have some cyber security standard that they can
yeah,
comply with?
yeah.
So do they
So
have some any piece of software? Does it have a
yeah.
mandatory ISO certification similar
No,
thing so that?
okay. So if it is critical software, let's say banking software and all, these standards are enforced by the government. Or let's if you are maybe targeting the Apple App Store, they have their own security requirements, and you have to develop according to that. Other than that, no, the OWASP top 10 that I covered is essentially open standards or essentially good recommendations. Apart from
Okay,
these, each government releases their own this thing. Okay, RSA
okay,
2048 bit is secure. Okay, this is it is secure. RSA current RSA systems are also secure, But one thing that is there is the threat of quantum computers. And RSA 2048 seems to be resistant to that too, because what quantum computers do is essentially increase your parallel processing capabilities. And current 1.5 is retired. Yes, 1.5 is retired already.
Okay.
Uh, s-
Okay.
so 2048, even with quantum computers, the current this thing is, yeah, it is still secure. Even with your Shor's algorithms, Shor and Grover's algorithms, it is secure, I guess, because of the key length size itself. It'll be hard to brute force, hard to factorize, even with a quantum computer.
Okay. Thanks,
Yeah. Okay.
Ishan. Yeah.
So another question I saw in chat. Yeah, I have worked on Shor and Grover's algorithm. I worked in Tech Mahindra's research lab before, in my second semester, and I've done a quantum secure messaging application prototype. And yeah, I've gone through these two algorithms specifically. I've simulated these algorithms on IBM Qiskit quantum computers. Yeah. Thank you. Chandrasekhar sir.